Okay, so I am starting today a revision of electricity and magnetism, and today I am discussing EM wave. Okay, so first of all, I will describe you displacement current, and this is here. This is ampere circuital law, that is integrate V into dl is equal to mu naught I, and you can also watch in figure, that is a magnetic field V, dl and I and vector r. It is a ampere loop. So current produce magnetic field. So in Faraday law, the changes we study changes magnetic field, produce electric field and induce EMF. And this is a Maxwell's. It is a circuit. Here current I flow, and there are two plates plus and minus, and that is move. So here is variable electric field produce magnetic field, and that is variable electric field is equal to electric current, that is displacement current. Okay, so now we are discussing ampere Maxwell circuital law, and this is the formula: closed integral B into dl is equal to mu naught Ci plus Cd. This is a total current. Here Ic is equals to dq upon dt, that is a conduction current, and Id is equals to epsilon naught d phi upon dt, that is equals to epsilon A dE upon dt, that is displacement current. Here there is a note, for wire Id is equals to 0, means displacement current to 0. Then closed integral B dot dl will become mu naught Ic, and for capacitor Ic is equals to 0, and it will become closed integral B dot dl is equals to mu naught Id. And third case, when Ic is equals to Id, then it will become closed integral B dot dl is equal to 2 mu naught Ic. Here we will study about Maxwell equation. So we will use two theorems. First is Gauss divergence theorem, that is closed integral A dot ds is equals to closed integral divergence of A dB, and Stokes theorem is closed integral A dot dl is equals to closed integral curl of A ds. Now we study Maxwell's equation. So there are four fundamental equations to relate to electricity and magnetism. First is Gauss law of electricity. So it is phi E is equals to closed integral E dot ds, that is equals to q upon epsilon, and that is del dot E is equals to rho upon epsilon naught. And third is Gauss law of magnetism, that is phi V is equals to closed integral B dot ds is equals to Ga. It is del dot V is equals to 0. Third is Faraday law, that is closed integral E dot dl is equals to minus del phi upon del t, that is equals to del cross E is equals to minus del V upon del t. And the third law is ampere Maxwell circuital law, that is closed integral B dot dl is equals to mu naught, then in bracket Ic plus Id, that is equals to del cross B is equals to mu naught, then in bracket J plus epsilon del E upon del T. And we will study EM wave, and stationary charge particle only produce electric field, and moving charge particle, when it move constant speed, means non-accelerated motion, then electric and magnetic field both are produced but constant. But when it move with variable speed, means acceleration motion, then oscillating electric and magnetic field will produce, here that is EM wave. And third is current carrying conductor, then only magnetic field produced. EM wave produced by hertz initially. Okay, so this is a diagram, XYZ plane. Here E denotes electric field and B denotes magnetic field. So they are both are perpendicular to each other, so you can watch by figure. Okay, and general wave equation 3D is del to y upon 1 upon v square del to b upon del t square del is equals to del upon del x I cap plus del upon del y j cap plus del upon del y cap cap. Here del dot del is equals to del square, that is equals to del 2 upon del x square plus del 2 upon del y square plus del 2 upon del z square. And these are EM wave equation for non-conducting medium. So V is equals to 1 upon root mu E. Yes. So that is del 2 E minus mu E epsilon naught del 2 upon del t square is equals to 0, and del 2 B minus mu epsilon naught del V upon del 2 V upon del t square is equal to 0. For free space, mu V will become mu naught and epsilon naught will become epsilon naught, and that is del 2 E minus mu naught epsilon naught del 2 E upon del t square is equals to 0, and del 2 B minus mu naught epsilon naught del 2 B upon del t square is equals to 0. And for conducting medium, del 2 E minus mu epsilon naught del E upon del t minus mu E del 2 E upon del t square is equals to 0, and second is del 2 V minus mu epsilon naught del V upon del t minus mu E del t upon del t square upon 0. It is a EM wave spectrum. So this is a short trick, Guy UV in my radio. So Guy is gamma rays, A means X rays, U means UV rays, V means visible rays, in means infrared, Y means microwave, and radio means radio wave. So here we study visual, there are waveguide. So when we move from left to right, then our wavelength increase, and so because n is equal to c upon lambda, so when lambda decrease, frequency increase. So penetration power increase when energy increase, and energy is equals to h nu. So when frequency increase, our energy increase and our penetration power also increase. So here it is energy density. The energy density is U is equals to E upon V, that is energy per unit volume. So electrical energy density U is equals to 1/2 epsilon naught E square, and magnetic energy density is equals to UV is equals to 1 upon 2 mu naught V square. Here EY is equals to E naught sin omega t minus kx, and VZ is equals to V naught sin omega t minus kx. And average electrical energy density UE is equals to 1/4 epsilon naught E naught square, and average magnetic energy density UV var is equals to 1/4 mu naught V naught square. So E naught upon V naught is equals to omega upon k, and that is equals to 1 upon root mu naught epsilon naught, that is equals to C. So UE is equals to UV var, that is energy of EM wave is equally distributed in electric and magnetic field. Now we will study momentum of EM wave. P is equals to U upon C, that is absorbing surface, and P is equals to 2U upon C, that is reflecting surface, and U is equals to energy, and C is equals to 3 into 10 to the power 8 meter per second. Here is radiation pressure. PR is equals to I upon C, that is absorbing surface, and PR is equals to 2I upon C, that is refracting surface. So I is equals to P upon A, that is intensity. Now we will study transfer nature. Okay. So electric field and is perpendicular to magnetic field, and that is also perpendicular to K vector. K is a transfer nature. So when E dot B is equals to 0, E dot K is equals to 0, and V dot K is equals to 0. That is a transfer nature. And we will study relation between E and B. So V is equals to vector K cross vector E upon omega, and mu naught is equals to B upon H. Vector E is equals to minus C square vector k cross vector v upon omega. And wave impedance is equals to z is equals to in mod e upon h, that is equals to under root mu epsilon, that is in ohm. And for free space, mu is equals to mu naught, epsilon naught is equals to epsilon naught, and mu naught is equals to 4 pi into 10 to the power minus 7. And impedance affected by medium to EM wave, that is z naught is equals to under root mu naught upon epsilon naught is equals to 1 by 20 pi omega and 376.6 omega. My next is Poynting vector. So when EM wave inclined on a particle system of charge, then it moves, that is del dot s is equals to E dot j is equals to minus del u upon del t, that is a differential form. And it is a integral form, closed integral E dot vector E cross h ds, that is a rate of energy flux, plus integrate E dot j is equals dot dv, that is a work done on system of charge, is equals to minus del upon del t integrate 1 by 2 epsilon naught e square plus 1 upon 2 mu naught v square dv, that is a rate of decrease of energy stored. This is a Poynting vector s is equals to vector e cross vector h, that is equals to 1 upon mu naught vector e cross vector e. Mu naught is equals to v upon h and h is equals to v upon mu naught. S, it represents the rate of flow of energy through per unit area perpendicular to the plane in the direction of propagation of EM wave. Here you can see figure intensity I is equals to mod s, that is equal to 1 upon epsilon naught E naught square c, that is equals to 1 upon 2 mu naught v naught square c. That it is a E, V and S, that is K, that is a energy upon area into time, that is joule upon meter square second, and watt per meter square. Next we will study solar constant. So energy incident on Earth's surface in per unit area in per unit time. Solar constant is equals to 11380 joule meter square second, that is equal to 1.4 10 to the power 3 joule per meter square second. Properties of EM wave is, it is a transverse in nature. Electric field is perpendicular to magnetic field and it is perpendicular to vector k, and vector E and vector V always in same phase. Speed in vacuum is equals to c upon under root 1 upon mu naught epsilon naught, that is equal to 3 into 10 to the power 8 meter per second. Speed in medium is equals to v is equals to 1 upon under root mu and epsilon naught. N is equals to c upon v, that is equals to 1 upon under root mu naught epsilon naught upon 1 upon under root mu epsilon, that is under root mu epsilon upon epsilon mu naught epsilon naught, that is equals to under root mu r epsilon r. Next it is a E upon V is equals to E naught upon V naught is equals to W upon K, that is V, and omega is 2 pi upon T, that is a 2 pi n angular frequency, and K is equals to 2 pi upon lambda, that is a propagation constant. Neutral in nature and don't affect in EM, electric and magnetic field. So it is our last lecture for EM wave. Now I am discussing my second last lecture. Now we will study, just give me only 1 minute. Yes, now we will study alternating current. So first of all I will tell you about directional current. So here you can see Y figure, it is a I and T, that is a direction. Okay, so direct current is magnitude and direction is fixed, and in alternating current I will discuss in next video. Okay, Thank you. So this is my next chapter to discuss. Thank you.